Hi everyone, greetings from TaiyangNews. This is Michael Schmela. I'm the Managing Director of TaiyangNews, and we all welcome you to our TaiyangNews webinar series. This is a series we do as part of our reports. We publish certain reports, and with these reports comes always also a webinar. This particular webinar today is on advanced module technologies, surprising developments leading to significantly higher power ratings of solar modules. That's a somewhat lengthy subtitle. The report was recently published at REI in India, and it is the third annual edition of this kind of report we're doing, and it provides an overview on the latest progress in the field of solar modules. The first presentation will be given by Shravan Chunduri, who's the head of technology, and he will give an overview. And then, as usual, with our webinars, we have always invited a guest. This is usually a leading company in that field. This time, we're very glad to have JinkoSolar, the world's largest solar module supplier. They will share details on their latest solar module innovations for very high power output. In particular, they will talk, and it's the first presentation online they're giving about their new will be given by Andrea Viario, who's the head of technical service and product management at JinkoSolar Europe. I would like to give the floor to Shravan, who will start with his presentation. Shravan, please.
Thank you, Michael. Thanks for the introduction. Hello, everyone. As Michael introduced, I am Shravan Chunduri, Technology Head at TaiyangNews. Welcome to my presentation on advanced module concepts. Here, I would like to put an asterisk to advanced module concepts. What I really mean by advanced module concept is the basic structure of the module does not change, but a little tweaking results in a boost in power. Slide 2. Next slide. Yeah, so before I go into my presentation, I would like to take this opportunity to provide a brief introduction of our company. So TaiyangNews is an open platform. We publish reports on advanced PV technologies. We also publish the market surveys on various production equipment and process consumables. The key differentiation with TaiyangNews is that it is an open platform. That means all the publications can be accessed for free. And then we also have a consulting arm called Mishko, through which we provide services such as communication, strategy development, and technical research and market intelligence, of course, for a charge. Next slide. Actually, my presentation is basically the adaptation of our report on the same subject, advanced module technologies, which just Michael mentioned, we released at REI in India, September this year. This is actually our third edition of the report. You can download the report for free at our report section of the website. And I would like to bring to your notice that this is a really short span of time in which I cannot really summarize the entire report. So I would like to walk through the key findings of the report. Next slide. So, as to the question of what really motivated us to do this report, in past, module makers were often relying on improvements at cell level to improve the module performance, but this is changing slowly. Module makers are now very active in employing innovative approaches to improve output power of the PV panels. The catch is independent from cell level. and module efficiencies or power ratings are going up, and this is also evident from the increasing cell to module power ratios, increasing number of bus bars, which have already seen like 3 to 4, 4 to 5, and some products are already available with 6. And then several companies are also working on the next level for the number of bus bars, which is nothing but multi-bus bars. And a lot of companies have successfully commercialized modules based on half cell, bifacial, and multi-bus bar. And then more and more companies are also venturing into shingling. So in summary, module making is becoming increasingly interesting and also very innovative. But before going into this presentation, I would like to make a note that it is really becoming very difficult to compare the module products, because there are really modules based on different cell sizes, then number of cells are also different. And so that means what I want to bring to your notice is that it is not very easy to compare in today's module products. But however, we stick to 60 and 72 cell module configurations for most of the power ratings. But in this slide here is this slide is about efficiency. So efficiency is a key performance attribute of the module. What we try to do here is, irrespective of the module technology, we plot the top efficiency of efficiency and corresponding power of the commercially available 60 cell modules. The modules highlighted in a different color are based on 6 cells are equivalent. Since the efficiency is somewhat independent from the cell sizes and number of cells, we put them here in for the comparison. For even this is also shown in our report. For other areas where we really talk about power, we strictly stick to 60 or 72 cell module configuration, though this may not be the completely right, but I think this is the most optimal way we thought we could do that. So what we can see from this graph is, as we all know, IBC is a premium technology that is entitled for high efficiency. This is also reflected here. SunPower's module have the highest efficiency of 22.8%. This is also applies to the other top efficiency modules from REC, which employs heterojunction, then LG, Jollywood, both of them are based on IBC cell technology. But what is also interesting here is, even based on a PERC cell technology, not that it's inferior, but this is really the standard in today's commercial production, Jinko's module is able to attain a good efficiency of 20.74%. So Jinko's module is based on a so-called tiling ribbon technology. In the next presentation, Andrea will provide more details on this particular technology. Actually, this is a brand new module from Jinko, so we were not able to put, so this is not included in our report. But actually, not just Jinko, several other module products that are based on PERC technology are able to attain efficiencies about 20.1%. So on the where you see on the towards the left, they are all more or less the PERC based modules, and they still have 24.1% efficiency. So what I would like to emphasize here is the standard modules based on high efficiency cells are topping the list, but products based on advanced cell module concepts are not really too far from these toppers. And next slide, please. Actually, we have also presented a similar comparison for 72 cell modules, but that's not here in the presentation, but you can find that in our report. Then more than the efficiency, rated power is the highest valued parameter of the module. Comparison of power is very complicated. Here again, what we did is we plotted the rated power of commercially available modules irrespective of the cell and module technology. So these two slides are helping to provide where the modules are when they are combined with cell and module technologies. So the observation is not completely different from what we see at module efficiencies graph. High efficiency cell technologies results in high power. Examples are REC, SunPower, LG, but even PERC at cell level, advanced module technologies such as shingling can lead to 370 watt module power, as is the case of Solaria. Then LONGi using M6 wafers attain also 370 watts. And then what is also interesting is companies like TaiyangNews using the same M6 wafer formats, which is 166.75, was able to offer a module with 345 watt, even with multicrystalline silicon. Next slide. So that means module makers are really working on all these advanced module technologies, and as of now, module makers are mainly working on 7 advanced module technologies. These are multi-bus bar, which is nothing but replacing the flat ribbons with circular copper wires, glass modules. They speak for the reliability. Bifacial, which opens up the rear side of the module for power sunlight absorption and power generation. Half cut cell, involving slicing the cell into 2 pieces. Shingling, interconnecting strips of cells similar to tiles. Then really 2 new advanced technologies came into our radar. That is a larger wafer format, which is nothing but employing larger wafer sizes. And paving is one technology. Of course, it has several names like seamless soldering or tiled ribbon. And so this technology is all about reducing the cell gaps or even eliminating the intercell spacing. And you could also see here that I have striken out more number of bus bars. As I mentioned earlier, this is our 3rd edition of the report, and we have covered this more number of bus bars from in our last 2 editions, since there was no progress, and most of the companies have paused their development in terms of more number of bus bars at 5, and then rather moving to multi-bus bars. So we have not put any major emphasis on this more number of bus bars. And what I would also like to note, bring to your attention is multi-bus bar, glass, bifacial, half cut cell technologies. They are widely used in production. So then larger wafer formats and paving are really the brand new technologies. So my presentation is mainly focused on large wafer and paving. I will highlight this 2 more, and I will also touch some commercialization aspects of shingling. However, all these technologies are widely covered in our report, which of course you can download for free at our website. Next slide, please. So the first technology I would like to speak about is increasing the wafer size, so larger wafer formats. It is really one of the simplest way to increase the module power. And 156 mm side length, which was called as M0, that has been the standard for many decades. Then M2, which is a 156.75, was introduced in 2017. Then M2 was more or less a standard in 2018. Since then, there was a race to increase the wafer size. Already in 2018, LG has been offering a module based on M4 wafer formats, which is nothing but 161.75, and Jinko's Cheetah modules were based on M3, which is 158.75. Then companies have been pushing the wafer formats, and TaiyangNews was the first to introduce very large wafer formats in current context, which is M6. It's 166.75. I think for multi, it's rather easy to do that. Then LONGi, which is the largest wafer manufacturer, they are now pushing for M6 wafer format. Then actually, for your reference, M6 wafers have a 12% higher surface area compared to M2. So that means the power gain moving from changing just the wafer sizes from M2 to M6 will also result in a proportional power gain of 12%. But that is not the stop. Even wafer manufacturer Zhonghuan has also announced that they're working on even M10 and M12, which is like 210 wafer format. So people would be thinking, it's probably very easy, so why not everyone is doing? There is also some difficulties. Up to M4 format, it is the wafer formats are compatible with the existing tool set, but M2, M6 requires some kind of change in production. So depending on the age of the equipment and the philosophy of the tool, like is it a batch or inline, and how it is handled, depending on these things, there is some change. So of course, all the companies which are offering, ordering the tools, now they are already preparing for these larger M6 wafer formats. Next slide. So the next technology, what I am talking is paving. As I said, so paving has different names. Actually, it is a very indigenous technology developed in China, unlike in past when most of the technologies were developed in West and rather imported into East. But paving is really a Chinese technology. The fundamentals of the paving is to reduce the intercell spacing and to provide pleasing aesthetics. So something very similar to shingling. Paving can be done in two ways. One is a Joytex patented approach, where they use a soft ribbon on the rear side and a triangular ribbon on the front side. Joytex is offering a complete solution, including the material supply and the special interconnection tool, which can also handle two different kinds of ribbons. But alternately, another method, like a lot of companies are trying to follow, is using the multi-bus bar, the round ribbon, and making it really flat at the place where it has to get onto the top of the next cell. So this approach is typically used with the half cells, which is already very mature technology. Lot of companies are really working at the background, but only very few companies were successful to offer the products on commercial scale. Jollywood is one company, and of course JinkoSolar has also recently commercialized the product. Andrea will give a detailed presentation on this their paving technology. So paving actually it gives a kind of an appearance that is very similar to shingling, but the advantage of paving is it really avoids using these expensive materials like conductive adhesives and a lot of laser cutting process involved with shingling. Next slide. So then I would also like to talk a little bit about shingling. So shingling is not really new. It's kind of a, right now it's been, technology is there for several years, but it had several issues. Like a lot of companies, there were several companies that have started up doing the technology, but very few have been able to reach the commercialization. I think there is also some patents issues involved in this, but compared to last year, what we saw is now several companies are able to offer the products on commercial front. So for example, Longi has introduced their model, and Tongwei is one more new company. Canadian Solar is also able to offer modules based on shingling. So at least we are able to see right now 7 module makers are offering products based on shingling, and 2 are even selling the modules with additional bifacial features. So shingling is also really reaching to the next level of commercialization. Next slide, please. So what is the most important advantage of these advanced module technologies? They are really compatible and they are very complementary to each other. So that means they can be combined to implement collectively to add up the individual benefit. So for example, one can combine a lot of technologies, bifacial, glass, multi-bus bar, and half cell. So in our report, next slide please. In our report we have really covered all this combination. In my next slide, I'm just showing a example, how the technology mix can work. So here I just showed you an example, but we have different combinations in our report, like glass, then only half cell, then only MBB, then bifacial with other technologies. So I thought this was kind of a lengthy sequence of addition of advanced module technologies. So here you can see that by adding such technologies, Trina was able to attain 425 watts with its passivated contact cells-based module, and in that combining bifacial, glass, half cell, and multi-bus bar approach. Next slide, please. So what I try to do here is really try to put the top of each of these technology mixes. For example, one just half cell and MBB, then half cell, then shingle modules, and all these combinations what we have covered. So this is a kind of a summary slide where you can see that each of the top of each of its class is now represented here. So obviously glass has nothing to do with the performance, so it is kind of the lowest. But so here what you can see is high efficiency cell technologies in combination with advanced module technologies can bring you onto the top, while using larger wafer formats combined with advanced module technologies is also really a promising strategy. The next slide. This you can also see in the 72 cell configuration, where the simple technology and larger wafer format are very advanced module technology, and simple technology can result in a higher module output power. Next slide. I think I come to the conclusions of my presentation. So as I explained, module makers are working on 7 advanced module concepts: larger wafer formats, multi-bus bars, double glass, bifacial, half cells, shingles, and paving. Every concept has its own set of advantages, but it also requires some different degree of changes and in implementation, in production process, and also the production equipment. So larger wafer format is right now the most simple and effective, but in theory it is rather than a trick than a technology upgrade, because it simply increases the module dimensions, so you have the higher power. So that's why sometimes not all these high powered modules result in high efficiency. Paving is the next hot topic. Actually it is an intermediate between half cell and shingle technology. So the performance wise it's similar to half cell, because it is implemented on half cell, but it doesn't really reduce the resistance losses as shingles does, but it really gives a pleasing aesthetics, a very less complex process. And more and more companies are offering products based on technology mix. So in the past there were a lot of companies were offering only glass modules or only bifacial modules, but this is now changing, which you can also see in our report. Like the companies which are offering individual technologies or only technologies are reducing, and more companies are trying to mix more technologies in one single module product. So there is actually no clear winning combination, because it again depends on a lot of parameters, like what is the cell size, what is the how many number of cells, and these are the things. And then bifacial is one technology that's really getting more and more acceptance in the field. Half cell is definitely on top when it comes to implementation in the production, and multi-bus bar is also implemented in a large scale. Thank you very much for your attention. Michael, it's over to you.
Wonderful. Thanks, Shravan. Thanks for this nice overview. So we continue with the next presentation, which will be followed by a Q&A. Please use the control panel to enter your questions, and I will collect them then and ask them. Next presentation is given by Andrea about their very interesting new Tiger module series. Andrea, the floor is yours.
Thank you, Michael, and thank you, Shravan, for your very nice overview on the technologies available currently in terms of high-end solutions for the most powerful or efficient PV modules. And thanks, Michael, for the kind introduction earlier. So as mentioned, the brand new module we want to, actually we have the proud and honor to present today is the new TR module series that was officially announced and launched last week only. So it's a brand new introduction of a completely new module type that we developed, and of course we will make available very soon to the market, as always at gigawatt scale, to fulfill the high demand for more powerful and more efficient PV modules to optimize the PV plant performance and investment return. Okay, so quickly summarizing on JinkoSolar, but just on two main points in terms of technology and capacity, because of course those are the two main focuses of Jinko as technology leader. So not only market leader in terms of market share and capacity and module deployment, but also in terms of innovation and research and development on new technologies, module efficiency, cell efficiency. Just to mention the last one that was achieved in terms of cell efficiency up to 24.58%, for instance. And in terms of market share, but refer to the capacity of production that we currently have, is to highlight how our innovations and technologies are not only concepts, but always based on a solid and mature production capacity, production technology, and production processes implemented since many years, and continuously upgraded and updated to deliver the best possible technology and reliable PV modules. So, and that's also applied to the new product that we want to talk about and introduce today. So this new module is planned to occupy a very significant portion of our production capacity starting from next year. So we are talking about a capacity allocation of minimum 4 gigawatts, for instance, for next year, according to the planning and production, and of course increasing later on year over year, ramping up depending, of course, on market demand expectations and success of this product. But clearly, our approach is always to consistently develop and produce modules which are accepted by the market because they deliver a real value to the market in terms of increasing profitability to the investors and increase reliability on technology and performance of the PV plant and the modules and the PV plant ultimately. So looking at, for instance, at the first aspect that I mentioned in terms of cell efficiency, it is clear the evolution if we plot that in this way, for instance, starting from, for instance, 2012, when already the capacity of Jinko was very significant, but the main steps that happened in the meantime clearly are identified by the big shift from poly to mono, for instance, happened by between 2015 and 2016, and then of course the shift up to half-cut cell configuration, for instance, that happened the year after. And then after that, it was a continuous improvement on optimization of production process, therefore optimizing the cell size and the cell shape, for instance, to maximize not only the cell efficiency, but also to increase the module efficiency, reducing the empty area that is not used for at module level. So therefore, the efficiency of cells and modules has continuously increasing over the past years, and the big jump that we are seeing right now, thanks to the TR technology that we are introducing now. Of course, we keep the trend in terms of cell efficiency increase, and moving to what happened, for instance, at module level to the next slide. We see that, of course, an increase on efficiency at cell level increases correspondingly the module power, the module efficiency, the module peak power. But what is the significant step up that we have thanks to this TR technology that we are introducing today is that not only the traditional 0.5% efficiency increase on cell level is exceeded in this case, but also the power class of modules keeping a very similar module shape and module dimension is achieved. You see that in this case, the plan for the next year peak power that we have for TR series is up to 460 watt. For a module which is based on a 78 cell configuration with a TR, so tiling ribbon. We will see later what are the details about this technology with the half-cut configuration at module level. So a very accurate study on the combination of the best and most suitable material technologies that we could put together into this module to achieve these results in terms of efficiency and power at module level. So the result on the portfolio is that we have basically three big groups of modules, which represents our entire portfolio at the moment. Is on the left-hand side our mainstream Cheetah technology that was launched last year, and since then was very well accepted and introduced into the market and became the mainstream technology not only for Jinko but very successful as a standard for the industry as well. In the middle, still based on our Cheetah cell technology, our Swan bifacial series, which comes with the two versions, with the double glass configuration and also with the more advanced transparent backsheet solution based on tether layer from DuPont. So also very focused on reliability and performance. And on the very right-hand side, the new product we're talking about today, the Tiger, of course, which is coming in both versions, monofacial and bifacial solution, because the configuration that we have with this module and combined with the cell technology is suitable for both monofacial and bifacial modules. And that's completing basically the portfolio for the high-end technology that we will have available for delivery starting from probably mid next year or Q2 from next year. Right, so let's look into the details of the technology and why this module is different. Shavran was introducing the different options that we have in the market already mature in terms of tiling, paving or tiling. Shingling, paving, or tiling. In our studies, we identified the tiling ribbon, the TR solution, as the most reliable and mature to assure a very powerful and efficient module, but also very reliable solution, because some critical aspects has to be very considered to make sure that the module is not only with the highest possible power and efficiency, but also durable and reliable in the field for a very, very long time, according to, of course, the warranty terms that we always give with our modules. So just to introduce the main points of this technology, one of the main shifts is from the 5 busbars that we have traditionally on our Swan and Cheetah series, up to the 9 multibusbar, or also known as multi-wire technology, based on different cross-section and shape of the ribbons or wires better that are used to interconnect the cells into the modules. That's also combined with, as shown in the pictures before, with the half-set configuration. Very important also because we know perfectly that, especially when the cell dimensions increase a lot as industry is going into that direction, clearly we need to, of course, compromise on the possible impacts that we have on reliability. So reducing the current at cell level is a very good way to increase the reliability and to reduce the hotspot effect, for instance, that we might have at module level. And of course, the main point is the interconnection, as I mentioned, of the cells, based on the so-called tiling ribbon technology. The concept is that we completely cancel the gaps that we have between the cells in the same string, therefore increasing, of course, efficiency at module level, but basically packing more power, having a much higher power density at module level, increasing efficiency. So using at best the space that we have in the area that the module can absorb light and convert it into electricity. So in terms of interconnection, I was saying that actually the shift is not only in terms of number of busbars, but also in terms of cross-section and shape of the busbars. We are not actually talking about busbar or ribbons properly anymore, because the shape and the cross-section of the connections is completely different. It is a round shape, and it's basically coming from a wire, which is soldered, of course, on top of the cell and connecting the cells in series into the modules. In this case, a very useful side effect that we have on this improvement is that we can increase significantly without any other extra effort or other add-on technologies like the so-called light reflecting ribbons or light capture films, etc. So we have this effect naturally thanks to the shape and the surface properties of these interconnections of these wires, because we increase clearly from a geometrical point of view the quantity of light that is reflected back to the cell surface and not wasted and reflected back to the air outside the module, and not used to convert light into electricity. One other very important aspect that it was somehow, of course, not optimized in the past, but in this case with this technology can be even further improved, is the performance at low light irradiance, a low light condition in low irradiance environment, because despite, of course, the power of the module is increased, the resistance of the ribbons and the module overall resistance is optimized to make sure that the module can perform at best, not only at the STC nominal peak power that we have on the label, but more importantly, when the light conditions are not corresponding to the STC 1000 watts per square meter, which is most of the life of the module. So basically, this is targeting the real performance of modules in the field to make sure that in the real outdoor life of the modules, it can deliver the highest possible energy yield that can be achieved. In terms of reliability, there are several points that, of course, has to be considered, and had to kept our R&D team busy studying this technology. And for instance, one very important detail is how to overlap and how to interconnect the cells one to the other. As you can imagine, the cells are, of course, as usual, very thin. So we're still talking about the roughly 200 microns cell thickness, probably a little even less. And then in this case, and you can imagine a metal object or something in between the cells, especially when laminating or when the cells are subject to mechanical stress, for instance. It can be very critical in terms of stress that can be triggering to the cells, and then potentially critical for cracking or this kind of problems. So to avoid all these, of course, it will study a special solution to basically guarantee that there is no stress, mechanical stress at cell level due to the interconnections. And that's achieved thanks to the special design of the overlap, because, for instance, in this case, there is the ribbon in between two kind of cushions that basically absorb the stress and make sure that there is no pressure, mechanical stress on the cells, for instance, and also studying the shape to reduce as much as possible the stress given by the height of the ribbon in between the cells. So reducing as much as possible the shading on the cell where the active area is, and reducing as much as possible the mechanical stress at overlap interconnection between cell and cell. Another aspect that, of course, is a plus for this technology, and that's actually in general, whenever we have the possibility to increase the number of busbars or the number of connections, that connection point or connection wire that we have on the cell surface, is that by increasing the number of ribbons, in this case, almost doubling the number of wire, the number of connections, basically we reduce by roughly 50% the possible impact that we have on cracks that can happen to the cells in terms of lost area or part of the cell which is not connected, electrically connected to the rest of the circuit because of cracks of the cells. Exactly. So that's also another side effect, positive side effect that we have, thanks to the fact that we can increase the number of wire or busbars or interconnections in general, passing from moving from 5 busbars to 9 multi-wire in this case. And then moving to the finished product, so talking about the module, looking at that from the feature point of view, and then also in this case talking about both versions, monofacial and bifacial. As I said, the module is available and will be available in both versions. And it's a very high-end combination of all the most mature and high-end technologies that can be used in the market today, in the industry today, to achieve the most powerful and efficient module possible. It's a combination of course, the hot cell technology, which have been successfully used in many gigawatts of production, not only from Jinko, but from most of the tier 1 manufacturers. And then in an increased number of busbars, which is increasing reliability and performance, of course, increasing the module efficiency and module power. And with the TR technology to reduce or to actually eliminate the gaps that we have between cells. So improving not only efficiency, but for instance, also aesthetics. So basically the modules will look much more uniform from the appearance point of view, and so being more suitable even for higher integration level for residential or distributed generation application in this case. Ultimately, also for a bifacial technology, and especially for the bifacial technology, of course, the purpose is to increase as much as possible the return that can be achieved on the investment by reducing the LCOE again to the lowest possible value, things that we achieved already successfully with our SWAN technology based on the bifacial solution, but can be further increased in terms of benefit thanks to this new development of the TR Tiger series. In case of the transparent backsheet version for the bifacial, of course, we have the same benefit that we had on our previous SWAN series, which is basically having a lighter module, which is very easily reducing the BOS cost, in some cases reducing the cost for installation and cost for the labor and structures needed for the fitting of the modules. And of course, combined with this transparent backsheet, which is exclusively for us supplied by DuPont, producer of Tedlar and the finished product backsheet, transparent backsheet, which is combining basically the transparency features for the performance of the bifacial and the reliability and durability of the tether foil. We already tested the modules for a while in the field, so to confirm that the energy gain and the energy yield is in fact higher than our previous Cheetah series. In this case, it has confirmed very clearly thanks to our studies. And interesting is to confirm also the fact that also in low light conditions, as seen in this in the square box highlighted here, that's achieved even higher performance, thanks to the fact that, of course, the performance at low light condition, thanks to the optimized resistors and 9 busbar configuration of the module, is really helping to achieve and to improve also on that level. In terms of reliability, of course, all our modules, all our series are tested even beyond standard. In this case, our internal protocol of course, make us test the modules for all the accelerated aging tests that can be applied according to the IEC standard. And all the tests have been passed successfully, even exceeding the previous series. So in this case, of course, reliability is always a very high focus for Jinko, durability, and that is keeping, you know, increasing continuously anyway. And in this case, it has been increasing even further thanks to the special connection, special design of the module that makes it even more reliable than the previous series. And then concluding with the last part in terms of course, final benefits and LCOE estimation, the very first impact that we have having a more powerful and a more efficient module is clearly the possibility to reduce the space needed to install the same quantity of modules, or sorry, not the same quantity of modules, but the same peak power. So in this case, the land area saving is almost proportional one-to-one to the efficiency increase that we have at module level, because we can reduce really the quantity of pieces that we have to install to achieve the same peak power at the installation level. And looking at the details of a direct LCOE comparison between our previous series, normal PERC, and then Cheetah PERC, and then ultimately the TR version, we can see that basically, of course, thanks to higher power efficiency, we can decrease very significantly the EPC cost, the land, of course, usage, and also the OPEX are reduced because, of course, we have to simply clean, for instance, a lower quantity of modules, or to prepare or to maintain a smaller area for the same peak power of the installation. Therefore, the LCOE is much reduced compared to, for instance, our Cheetah series, and even in a comparison between our Cheetah series and previous Eagle monoPERC, the reduction in LCOE is even more significant. And of course, proportionally, the increase in IRR is also achieved thanks to the ultimate LCOE reduction that we have in this solution. So to summarize, is the benefit is at different level, but it's covering the overall downstream segment of the industry, covering all the engineering, procurement, and construction, and then of course even operation and maintenance of the plant, reducing the number of strings, for instance, that we need to install for the same peak power by increasing the module and module power and module efficiency. In terms of course, also in procurement, of course, we can decrease the EPC costs thanks to the higher power class of the module. And in terms of construction, of course, we need to use less modules, we need to use less area, and therefore the construction costs are also reduced proportionally. And that's a conclusion for today. And of course, now, Michael, back to you. And thank you for your attention so far. And I think we have probably a question and answer session following. Thanks.
Okay, wonderful. Thanks, Andrea. Great overview, exciting product. So we have 10 minutes, a lot of questions. So please, Andrea, Shravan, very short, brief answers. Maybe the first question, I think the products looks very exciting. Andrea, can you give us an overview on what can we expect in terms of production capacity? When will it be exactly available, and how much of the product will be available from?
Absolutely. We are right in the middle of the technology transfer and ramping up production right now. So in the next 1 or 2 quarters, we will be optimizing production and increasing capacity. We expect starting from Q2 next year and then up to the end of the year 2020 a capacity of roughly 4 gigawatts, and then it is supposed to increase proportionally year over year up to according to our roadmap up to targeting 10 gigawatts even from 2021. So really rapidly transferring the capacity, reallocating the capacity to this product.
Okay, looks like you're really betting on that product. So Shravan was somewhat saying that he considers paving sort of an intermediate between half cells and shingles. How would you see that? Is paving your ultimate bet now, or would shingle also come next?
Yeah, I mean, so
Let's maybe
Andrea
first, and then.
Sorry, I tried to reply very quickly. Yeah, as you said, it's our bet, but clearly based on solid analysis and really thorough evaluations on technology options. Clearly, we believe this is the most reliable and mature technology that can be used, and that's the reason why we keep focusing on this. And we will be using this technology going on for sure.
Okay, Shravan, quickly.
Yeah, so I think what Andrea said is right, but paving is a technology that is right now in principle, technology-wise, it's a kind of a half cell technology because it cannot really reduce the resistance losses beyond half cell. But on the other hand, of course, shingling can do that, but shingling is more complex to accomplish in production. So it also requires other materials like conductive adhesives, which are considered to be expensive, and you need lasers, and the entire process is really more complex. So I really don't know whether shingling can really go into the mainstream. Of course, there are some I see there is a lot of momentum, but still not everyone who has started with the technology have finally succeeded with the technology, whereas paving is very less complex and rather easy, not for everyone, but at least for companies who are seriously working on that. So for example, Jinko, they have really managed to come out with a commercial product for a technology which was not so well known. I mean, last year no one knows what is paving about, but now I think this is such a short span. If the technology has gotten out to the commercial stage, then I think it's yeah. I think this is really, it has ease of transformation into production probably makes paving more advantageous.
Okay, thanks. Andreas, so you said you went from, you chose 9 bus bars. So why did you exactly go for 9 and not 12 or pick some other numbers? Because of course that could theoretically have even more advantages.
Very good question. Well, the main point is that of course by increasing the number of bus bars and wire, in this case multi-wire, we can increase the module efficiency, module power clearly, and the combination, especially with the half cell and multi-wire and TR technology, is really the best combination from our analysis and study to achieve that. The fact of moving from 9 to 12, it's a big effort. I mean, in terms of technology and production, the yield in production might be affected because it requires some more improvement, let's say upgrades on lines, and but it's not corresponding to a proportional benefit on the overall result in terms of module efficiency and module power. So that's the reason why we believe this is the best combination to achieve module power, module efficiency, higher module efficiency, without making it too complex or too risky at production level, reducing the yield of production with a more complex solution.
Mm-hmm. So the Tiger module, was it originally developed with the residential sector in mind? Because of course you have also this aesthetic factor, or is it also really focused as well on the utility sector?
Both, actually. We actually started from the utility sector because we understood that there is no real big improvement in enlarging the module size and cell size anymore. So we wanted also to address that need from the industry that is requesting for higher efficiency modules to optimize the cost structure downstream at BOS level and EPC level. Clearly, the challenge at that point is really the cost of the module that might be increasing slightly, without even giving details about price, which are probably not in my mind right now. But clearly, it's a combination of cost of components and cost of BOS. Clearly, cost of modules and cost of BOS. But in terms of fits with the industrial and residential market, clearly we see also very high potential, especially with a combination of black solution like black frame or black backsheet, which is even probably not necessary almost anymore, because the appearance of modules is really almost uniformly black. So really improving on that aspect a lot. So we expect also a lot of success also on the distributed generation and residential industrial segments.
And so when you talk about utility scale, so that means it's obviously also compatible with tracker systems.
Indeed, yes. Of course, the thing that we are, of course, carefully targeting right now to have the best combination also with the BOS and structures, for instance, is the fact that, of course, it is mechanically compatible. Clearly, there is no challenges in terms of fixing practically on the structures and trackers. No problem. Is rather on the electrical configuration the focus right now, because of the different cell configuration into the module. We are changing slightly the current and voltage parameters at module level, therefore at string level. So right now we are really looking for the best combination of or array layout to optimize even further the BOS and the design of the PV plant to achieve the lowest possible SCOE in the end.
Okay, so one technical question. So larger wafers obviously increase current, while half-cut cells decrease current. Is there any optimal cell size with respect to current and resistive losses? And when going to M6 wafers, do you expect to see, for example, a 1/4 cut cells? Show maybe that to you, and also Andrea, if you think about that when designing your products.
I don't know if Chevron wants to comment first, or
yeah. So I think the finding an optimum is really difficult, because then a lot of things also play. But if you really think that, okay, if you are doing something like M6 wafer, then it makes really a lot of sense to do half cells, because it can really compensate for the current losses. I mean the resistive losses. But where is the optimum? I think it's difficult to say. This really depends on changes from manufacturers to manufacturers. But on the other hand, I think half cells has really gotten into the mainstream in a big way. Some companies have really planning to shift 100% to half cells. So this is also actually this is also keeping in mind of larger wafer formats in their roadmap.
Andrea?
Yes, as Chevron mentioned, it's hard to find there is so many options that it's really difficult to find one which is good for all the conditions, especially because, of course, it's not only a matter of optimizing the voltage and current parameters at module level. We need to think of the module operating in the field, and not all the latitudes, all the conditions are equal clearly. And therefore, a good module optimized in some locations can be probably not the best one for other ones. I'm talking about very hot climates or very cold climates, or very high radiance climates, or very diffuse light radiance climate. So it's really difficult to find a best solution for all, but with this configuration, it should be the best possible for for the giving partially benefits for the all possible configurations and locations. And that's what, of course, we have to address, because our modules are installed and used in any possible location and configuration. So that's also, the big challenge for us is to take into consideration all the possible needs given by the different designs and different locations for the PV sites.
Okay, wonderful. I think we have 4 o'clock CET now, so I think there's still more questions. If you would like to have that answered, please get directly in touch with Shravan or with Andrea. I think they will be happy to get back to you. Thanks to all of you for staying with us. The report and the recording, or the presentation and the recording will be available within 3 days. We would like to invite you to come back and join us for our upcoming webinar on bifacial solar module technology. That will be on December 3rd. That's when we will introduce our then new report on bifacial solar modules. Thank you so much for joining us. Thanks to the presenters, and have a nice day. Bye-bye.